Hello, Math 3 class. So I hope you enjoyed your days without power. Don't know how enjoyable that would be. But so what we had planned for Wednesday, the 14th, was to continue working with your modeling college tuition project. So you should have completed steps 1 and 2, and I'm going to be looking at those over the next few days and giving you feedback. So definitely be checking Canvas. You want to try to get these to be green, get that full credit. So you should have picked your tuition, your college university, created your table and scatter plot to look at where the tuition costs have been, made some observations, and then the last thing you were supposed to do was make an estimate. Do you think that this was a linear growth? Do you think it was some kind of polynomial like quadratic or cubic or something? Or do you think it's exponential growth, and why? So that's where you should have finished. So this next day should have been steps 3, 4, and 5. Step 3 is actually, I'd forgotten. I had just actually made a spreadsheet. So what I would like you to do for step 3 is if you click on that, it's just going to create an empty spreadsheet, but this is going to give me access to view your data in Scatterplot. So if you could just copy and paste your table and Scatterplot from the original Google Sheet into this one, that's going to let me see it, and I would really appreciate that. That'll just help in this. So that's a real easy step. And then step 3 should be done. So then we're going to look at steps 4 and 5. And really 4 is the only one that's anything new. 5 is just wrapping up everything so far that we've done, kind of like a summary write-up. So step 4, what we're going to do is we're going to run various regressions to determine what actually is the best model for the data. And so I have a mini lesson plan because you're probably going, what the heck is regressions? You should have learned about this in Algebra 1 or Math 1, possibly Algebra 2. But I'm going to give you a quick rundown on that. So you should have linked in the announcement to this page right here. So you're going to want to get this page out because you're going to want to take some notes on this. It's going to help you with your project. Okay, so just kind of starting at the beginning. This is just a random, we looked it up last year. It's sculptures, I think at UC Davis is where that is from. So gathering data and making predictions. You've already gathered data. Now we're going to make predictions. Okay. So far you should have chosen your state, college, or university to focus on. You should have created your table of data and your scatter plot. And this is for both schools. This is kind of, so this is just one school. So that's for one. Oops. Okay. For your one school. This was a from an old activity. It's been like updated, so from one school. And then you should have created your scatter plot and then kind of come up, not necessarily having your line of best fit, but what you should have done is had a prediction of the model type. So this is what you should have done already. Okay, so things that we're going to be doing today is we're going to be looking at correlations and data tables. Okay, so things that we're going to cover is you're going to be able to, by the end of this video, define and explain what and how R-squared and correlation relate to your project. You're going to be able, so here's that word again, take regressions of the data that you've already pulled, not for both schools, just the one school, and then explain the fit of those lines and compare and contrast it with your initial prediction. What did you think? Okay, so the next part of your project is asking you to test, is your prediction linear, the polynomial one, exponential. Is it correct? Which one will be the best prediction for your future tuitions for the school that you selected? So that's what we're going to learn how to do. All right, so make sure you have this out. You're going to see you might need to pause the video to write down some definitions for these to fill in the blanks. I'll try to remember and tell you here's where you should pause and make sure you have this to refer to. Okay? So, definitions. So you want to make sure that you get these. So those two blanks right here, correlation, and then the coefficient of determination r squared. Oops. So correlation, the actual definition is it's a mutual relationship or connection between two or more things. It is not, you should have learned this in Math 1, it is not a cause effect. It's just describing, is there a relationship? This is for linear models only. We can only describe correlation for linear things. And so this is when we talked about, like, you could have positive correlation, which means like your points are kind of going like uphill. It tells me as one increases, the other increases. It can have negative correlation, which tells me that the points are going downhill. As my x increases, the y points are getting smaller. Or you could have pretty much no correlation, and that means there's not really a relationship. It's kind of all over the place. Okay? And it can kind of be closer. So this would be a positive 1. If it's in a perfect line, the closer it gets to positive 1, the more perfectly the points are in line. They might be like some kind of out here or down here, so it might not be in an exact perfect line, but they're kind of going uphill. If it's exactly in a line going downhill, it's negative 1, and then no correlation is 0. So that's what it ranges between. So that's correlation. Then we have what's called the coefficient of determination. Correlation is always described with a lowercase r. The coefficient of determination is described with a capital R squared. Okay, so we call it r squared. It is a statistical measure. If you take statistics, we're going to get into a little bit more of this. It's a statistical measure of how close the data is fitting, and this one can work for a regression line or curve. So that means it can work for linear, it can work for quadratic, it can work for cubic, any of those polynomials. It can also work for exponentials. So, whereas correlation only works for linear, the coefficient of determination r squared can fit any of these. And it's a statistical measure. So this one's describing a relationship. This is a statistical measure of how close the data fits, how close do those points fit to the actual like line. So what we're going to do is we're going to create like an equation. So this one would be like a line, this one would be like a quadratic, a cubic, or an exponential. So we're going to create an equation, and then the r squared tells us how close do our data points fit to this line or this curve from the equation that we created. Okay? All right. So let's go on. Make sure you have these notes. Okay, so correlation. So for example, we can compare like grade point average, hours spent studying. So we can see all it's describing is a relationship. It's not saying that your grade point average causes this or this causes this. It's just describing as a trend that they notice. Sometimes they call these trend lines. As the grade point average increases, we notice the hours spent studying increases. R squared, so remember, it's a statistical measure of how something fits closely. So here's this line. So this is our fitted line, the equation of the line, and we can see these points are our actual responses. So the observed responses and then the fitted ones. This one, we can see they're a lot closer. So this is going to have a higher R-squared value because the points are closer to this line. Does that make sense? Like I can hear you saying, no, Mrs. Carr, you're crazy. So R-squared is defined by the explained variation out of just the total. So there's statistical measures that can go through. So the explained is what we expect to happen. So I expect as this goes up for this line, like we have this kind of like slope of the line. This is what's explained, but all of these points that aren't on the line is not explained by our equation, okay? So R-squared is taking what can be explained out of what is the total variation. So it's like a percentage. Taking something out of the total is always a percentage. So remember, percentages can range from 0% to 100%. Or if we change these to decimals, 0 to 1. So R-squared always has to be between the value of 0 and 1. So like 0.90 would be like 90%, okay? 0 would indicate that the model, remember the model is referring to our equation. Our equation explains 0% of how our points change. 1 means that the model, remember model's equation, our equation explains 100% of the variability, that all of the lines fit perfectly onto the graph of that equation, okay? The closer, so notice with R-squared there is no negative values. It's only between 0 and 1. The closer that R-squared is to 1, the better the fit of the line. Okay, so that's key right there. So I think some of these should have been on your notes. If you didn't get that, pause, check, make sure your notes are filled out so far. All right, so here's kind of just a breakdown. This is also on your notes, so make sure you might pause this, write this down. Okay, so kind of giving a breakdown. So we said 0 is absolutely no percent, no fit. 1 is a perfect percent. That's that 100% of the data fit. Okay, so 0.9 to 0.99, this would be like 90% to 99%. So we say this is a very strong correlation or fit. We don't really want to use the word correlation because it's not, it's the coefficient of determination. So we're just going to use the word fit. Okay. Some of these values could apply to correlation, but then there's also the negative values too. So that's why it's there. But I just like, if we're talking about R-squared, using fit. So 90-99 is a very strong fit. 80 to 89 would be 80 to 89% of the data is explained. That's considered a strong fit. 50 to 70% would be moderate. And 10 to 40% would be a really weak correlation or fit. And then anything less than that, we really wouldn't say that it's a good fit at all. And really what we're wanting to get up into here, these are our good fits. Once we start getting below 80%, not so good. Okay? All right, so if you haven't gotten this written down in your notes, pause it. Make sure you get that. All right, so the type of regressions that we're going to learn about, and this is what you had to pick for, and really I told you polynomial. Let's just kind of we're going to limit this to either quadratic or cubic, and then exponential. So you should have picked one of these, what you think, just eyeballing it, looking at your data. Okay. So now I'm going to run you through how to do regressions on your spreadsheets. Okay, so you should have your spreadsheet of data opened up. Or if you want to watch this and then kind of go back, maybe have both of them pulled up at the same time. So here's some spreadsheet data as it is opening. All right. Let me get rid of these. All right. So this was just some data that I had. I don't even remember which college this is from. Here's the years. I rewrote it because we said to use these. I think mine still started off with 2000. I mean with 1999, but that's fine. All right. So notice here I actually have a trend line, and I'm going to click edit and show you how we got that. And so we're going to go to customize. Now I got to remember. Oopsie, sorry about that. Awkward. I think it's under series. Yep. So under series, so you should have probably just seen that it disappeared. So here's that. So we're going to click on the 3 dots, and then you're going to go over to customize, and then you're going to click on series, and you're going to come down and notice that there is, so here's my nice little scatter point. Here is my trend line. So I click on that, and the first thing that it brings up is a linear. And if your equation is not showing up here, make sure down here in label, so I'm still under series, we've clicked on trend line, so it's right here. If your equation's not showing up under label, click on that and put use equation. And so now we can do that and see that. Notice there's also an option next to it to show what r squared is. So let's click on that as well. Okay, you can change the so the opaqueness is like how, kind of notice that my color is a little bit lighter, so I could make it like darker or whatever. That's what that is. So it's using the same color but just a different shade. You can change the thickness of it. Don't make it too thick. You can change the line color. So notice it started with linear. So this is actually the best fit. So we can see right here, this is in slope-intercept form. So my equation would be y equals 544x plus 4,576. So there's the slope. That's how much it's estimating it's changing every year. There's the y-intercept, that starting amount. And I can see that my r squared is 0.905. So that's a 90% fit. And we said that was strong. It's right there at that borderline of strong, but it's strong. Let's see if we can get something better. So I'm just going to go through and kind of keep an eye track, okay? So now I'm going to change, from linear, notice I have an exponential. So I'm going to click on exponential. And then it changes it, and it's always going to give exponential as continuous compounding. That should sound familiar. So notice we have E, our Euler's number. So we have that 4,921 times e to the 0.0729x. So we know from our first unit that this is our starting amount, and our rate of growth is about 7%. So it's continuously growing at a rate of 7%. And my r squared value for this one is 0.919, so about 91, 92%. So I can see that that's a little bit better. And then we can click polynomial, and then polynomial then gives me the option of degree. And I told you I only wanted you to use quadratic or cubic, so that'd be degree 2, degree 3. Because it's obviously going to get, notice with degree 5, it gets really close, but we also want to make sure that our model fits our context. And really, like a degree 5, we're not gonna the only reason why we know this is because of the points. Okay, so we're thinking just kind of quadratic growth, so it gives it to you in, it's kind of like standard form, but it's backwards. There's your y-intercept, your bx, and then your x squared. So it has about 91.18, so kind of seeing quadratic growth grows faster than linear, not as fast as exponential. So there's that one. And then there is polynomial if you wanted to try cubic. And so it's up to you. Just because the r squared value gets higher, it doesn't mean you necessarily want to use it. You also want to think about what's the long term? How is this going to grow long term? What does this mean in context? Okay, picking those things and taking that into account with it. So you're going to pick and say, okay, here is my value. This is what I think it is. Okay, so let's go back. So that's how you do that. Okay, so our next one. So when you're in your write-up, some things that's going to ask you as you're talking about it. So let's look and see what that checkpoint looks like. So this is step 4. So you're going to be, so it says run at least 2 regressions. So you need to pick at least 2. Which ones did you try? So you need to make sure and put both of them in there. Provide screenshots of the regressions. And I have using Desmos. I actually want you to just use the spreadsheet. Okay, so you should have the 2 screenshots, and I should be able to see both the equation and the r squared. So tell me, I tried this one, here's the screenshot of it. Okay, or you can copy it like I showed you, try another one, do that. So make sure you get both of those in there that show how well they match it. And then discuss limitations and advantages. What is the downside to some of these? What is some of the advantages? And then to identify those key features. Remember how I was talking about that, like here's the slope. This is how much it's growing each year. Here's the y-intercept. That's the starting amount. If you use exponential, here's the starting amount. Here's the growth rate. What's that kind of thing? What do they mean in context of the college tuition? Okay. And then which one do you think is the best fit? How do you know? Make sure you include the relevant terminology like r squared. Don't worry about residuals. That's for like statistic stuff. The inner slopes, the intercept slopes. Are there any outliers? Maybe that might make it. Because remember, if we have 1 point way up here, most of them may be close. And if there's 1 point way out here, there's a one weird year, you know, it could affect that. So maybe we want to kind of ignore that one, you know, and that could affect the r squared, but we may choose to kind of ignore that. Okay, so that's so far what you should have done. Now what you're going to do is you're going to research the actual cost for your school in the 2 recent years. So this would be, you could use this year, 2018, so you could do 2017, and this year, 2018, 2016, 2017, and this you're just going to have to Google that and find that. So then what you're going to do on your table is you're going to actually have to skip down. So let's say, and we were starting off with 2000 as year 0. So let's say you found the costs for 2017. So that would be year 17. Actually, we would put it like right here. Year 17, and then put what the tuition cost is, and then year 18 and put what the tuition cost is. And notice my graph is changing. And if your graph doesn't pick up those points, you need to make sure that you go here and click edit chart and change that data. So you might have to click on this data range and then click this and then you can like re-highlight that or change that. So notice this says A16, so A16 starts right here. So notice I just clicked in here and then re-highlighted, and it's changing it. So make sure that those points get added to it. So research, find the previous 2 years tuition for your college, okay? And then determine, does your model accurately predict the cost? Okay, so did it change it, or did your model change, or was it pretty close? Okay, so what you'll need to do is first use your model to predict it. So you would plug in like 16 and 17 into your equation, okay? So we'll come back to that in a second. So here's like your model. To predict it, you would plug in like 17, so this one's a linear. We would plug in 17, 18, 19, 20, and so forth, and then predict that. Does it adequately predict it or not? Okay? And then if not, use these data points to improve your model. So if not, go back and change the model and include those, okay? And then use your improved model to figure out, okay, so now that you have a new one, what are going to be the costs of these 4 years, starting in fall of 2019, 2020, 2021, 2022. And we're assuming you're going to go for all 4 years. So you're going to have to use your model to calculate what are the costs, figure all of that. I don't remember why there's a box here. I don't think you need it. And then you're going to ask which type of regression makes the most sense for predicting costs in the future. So think about the long term. Okay, like which one do you think is going to be best and why? And you don't have to go back and change it, just also, but if you know that now, you can use that to help determine your decision. Okay, so as you are, I think up here, which one, like including relevant terminology, that kind of thing. So that's what this is. So thinking about what are advantages, disadvantages, the key features, those are those questions I said to make sure that you answer. Okay? So make sure that you use a calculator to plug those into your equations. Okay? Get that equation done, and then figure out, okay, what that is. So that's the rest of step 4. So this is where the majority of your work is going to be for this part. And then the last part, so step 5, this is just a write-up. So you're going to take the information that you've done and written about in steps 1 through 4, and you're just going to it's going to ask you to summarize it. So in the space below, you're just going to describe the college or university that you chose to research, what it was that interested about you. If you already have that, you can copy and paste it from one of your other ones. What's the tuition cost? Historically means in the past. And then how much did you predict that it's going to cost for you? What's that total amount that it's going to cost for you to attend those 4 years? And then you may want to include any non-tuition. If you want to, this is your choice, that you've noticed, oh, I'm going to have to pay to live on campus, or I'm going to be able to live at home, or things like that. So just this is a nice kind of little summary of that. Okay? All right, if you have questions, shoot me an email. I'll be checking my email over the next couple of days, probably through at least Monday of next week, and then I'll take a break for Thanksgiving, and then probably pick back up that Sunday at the end of Thanksgiving before classes return. So make sure before you come back from Thanksgiving that you have steps 1 through 5 completed for your modeling college project tuition. Okay? Modeling college tuition project. There it is. All right, so that is it. If you have any questions, let me know, and I will see you after Thanksgiving. Bye, guys.